Alright, this is our next set of notes in Unit 1, partitioning and line segment notes. We just finished midpoint and endpoint notes and our practice and stuff on that. And that was midpoint and endpoint of a segment. So this is the next thing we're going to do on a segment. It's similar because you're still kind of splitting a segment like you did with midpoint. But a little dissimilar because you're splitting the segment into ratios based on numbers that are given. So it's a little bit more complicated, a little bit more entailed, but it's still down the same path of what we did the last couple of days in class. Alright, things you might want to graph before we start. I have a ruler, I have some extra paper, notebook paper, because there's some problems that won't fit on the actual notes that we'll have to transfer the paper just to show our work. And then I also have different color pencils and a highlighter. Different color pens and a highlighter. Now, you don't have to have different color pens. You could just use your pencil or pen, whatever you're using. But I like to color code stuff as I go. If you want to do that same thing, you can. But that's very optional. If you don't have a ruler, too, you can use anything as a straight edge. Most of my kids last year and years before used their IDs because that's something they usually have on them. All right. There's a lot of stuff we're going to go through, so I'm going to try to do it as fast as possible so I don't lose you guys. So here we go. At the top, just some vocab. Partitioning and line segment. To partition, a line segment means to divide. The line segment into a given ratio. The two numbers in the ratio must add together to equal the total number of pieces. The vocab is always there just to give you a definition, but to see what we're really talking about, we're going to come down here and actually apply that language. Down here we're just going to do some simple partitioning of a segment, and just to get you acclimated. Alright, the first one, it says label point P that partitions the line segment AB in a ratio of 3 to 2. 3 to 2. Alright, all they want us to do is split this line in a 3 to 2 ratio. So you really just got to start at A, because it said from A to B, and split the line into 3 to 2 pieces. You can, before you even do that, you can count and see how many segments you have, which is 1, 2, 3, 4, 5. So it's got 5 segments. So split it 3 to 2. And start on this end from A, go over 1, 2, 3. This is a split of 3 right here, and then my other split would be 2 right here. So my partition point would be right here. This would be point P for me in the 3 to 2 split. And then to figure out, like I said, how many segments you have, you could just do it at the end, honestly. You go 3 plus 2 equals 5. So you have 5 segments in total that you can split that line in based on the ratio they gave you, and we did 3 to 2. The second one, they asked us to split it 1 to 4 from A to B. So from A to B, I'm 1 over 1. That's my first split. The other split is going to be 1, 2, 3, 4. And this is 1 to 4, and this is a 1 plus 4 split, which is 5 segments again. The main thing I want y'all to understand too, you're not counting the points, you're counting the segments. You're not counting you're not counting points. I think kids think you count the points to figure out the splits. You're counting your segment, the line segment in between. So I'm really counting this line right here. 1, 2, 3, 4, 5 line segments. Alright. labeling point P. That partition is 2 to 3. So 1, 2, and this is from A to B. I keep saying from A to B because sometimes they will tell you from B to A and you have to go the opposite direction. 2 to 3, 5 segments. Alright, let me see. This is simple because it's not on a graph. Oh, I'm sorry, I didn't put my partition points in for y'all. It's going to be important to identify that too. Point P and point P at those points. Alright. Determine the ratio of the directed line segment AB when partitioned by point P. So this line is already partitioned down here. They just want to know the ratio of the line based on the partition that they're doing. And the first thing you want to do for yourself is figure out how many segments you have. Looking at this, you got 1, 2, 3 segments. So you got 3 segments here. And then from there, I want to see how they partition those 3 segments. It's pretty obvious to see that from A to B, they split it 1 to 2. The second one, they want to see the ratio for this line segment that got partitioned. Looking at it, I count 1, 2, 3, 4, 5 segments. And then from there, let's see how they partition this. They partition it 1, 2 to 1, 2, 3. The last one, looking at it, I want to see how I partition this one. So 1, 2, 3, 4, 5, 6 segments. And they partition this one 1, 2, 3, 4, 5 to 1. Now it's just simple partitioning. We're going to have to do our partitioning on the graph for our coordinate plane, which makes it a little bit harder for us, but it'll be alright. Alright, so here are the rules if we're going to do this on the coordinate plane. The first thing you need to do, and you have to follow these steps. You can't try to shortcut it or do whatever you want to do, because some of them will be easy. It'll be whole numbers, but a lot of times with the partition that we do, you're going to have to deal with fractions and stuff, and following the steps will help you deal with the fractions and things like that. The total determined number of parts the line segment is divided into. That's kind of what we were doing up here when we decided how many segments we had, 3, 5, and 6. So you just need to determine the total number of parts based on the ratio they give you. That's step 1. Step 2, determine the length of the horizontal and vertical distance from endpoint to endpoint. So on our segment, we're going to determine the length of our horizontal distance from one endpoint to the other endpoint, and then our vertical distance. For y'all who don't know what horizontal and vertical are, horizontal is your left or right movement, and vertical is your up and down movement. We're just going to figure out how far we went horizontally from one endpoint to the other, how far we went vertically from one endpoint to the other. We're going to write those numbers down too as well. By doing that, we're going to actually make a triangle when we do this. On our graph, we're going to create a triangle, make a right triangle. Let's be specific. Making a right triangle will help us find our horizontal and vertical distance. In step 2. Step 3, we're going to divide each length by the total number of parts found in step 1. So once we get our horizontal and our vertical distance, we're going to divide both of those lengths by the total number of parts in step 1. And then from there, once we get those numbers, when we divide, we're going to count from either endpoint the number of parts used to form the ratio. So those are the steps. I mean, like I said, with anything, until you see it, you're not going to fully grasp what I'm trying to tell you. But so let's go on the back and do it. first one on the back. It says given points A 3, 4 and B 6, 10. Find the coordinates of point P on a direct line segment AB that partitions AB in a ratio of 2 to 1. The only thing that's important to read on these is which way you partition it. Most of the time it's going to tell you from like A to B or C to D, whatever letters you use. But sometimes, and I'm even going to show you on the next one, sometimes they'll switch it up on you. On this one they say from B to A. On number 2, so on number 2 we're going to have to partition from B to A. We're going to reverse the way we partition. You just got to pay attention to the way they name the stuff. Alright. So the first thing I want to do, I want to graph these points A and B. A is at 3, 4. B is at 6, 10. This is point A. This is point B. And like I said, if you have a ruler, you can connect that line real quickly for yourself. And then I'm going to start following my steps after that. Step 1 says to identify how many segments my line had. The ratio is 2 to 1. To figure out the number of segments, you do like we did on the front. We had, if it's split 2 to 1, that means there's 3 segments in total. So 3 segments in this line. All you got to do is add 2 plus 1. Don't overcomplicate that part. And then from there, after you figure out the number of segments you have, part 2 says make a triangle so that you can figure out what your horizontal and vertical distance are from endpoint to endpoint. So on my graph, this is where I want to make my triangle. In the graph, and I'm going from A to B horizontally first. Horizontally from A to B, I have to move to the right until I land under B. When I move, I want to figure out what that count is too. You gotta understand which way you're moving to so you can write your numbers down right. If you're moving from A to B to the right, that is a positive movement. Going from 3 to 6, that's moving in a positive direction horizontally. I move from 3 to 6 too, that's a plus 3. That was my horizontal change, plus 3. And then I want to figure out my vertical change from A to B. So to get from A to B, I would have to go up. You need to figure out what this vertical change is too. Hopefully you understand that moving up is moving in a positive direction too. I went from 4 to 10. That's a plus 6. It's important that you have the right signs in front of your numbers too, especially when we start doing this math over here. Alright. So out to the side here, I'm going to do the math to actually do my partitioning. Okay, so I got my 2 changes, my horizontal and my vertical change. My horizontal change is going to be, and I'm going to just label with an H. My horizontal change is going to be 3. My vertical change is going to be 6. I'm going to label that with a V. From there, you want to do step 3, which is dividing your changes by the number of segments that you have. The number of segments, we wrote that up here at the top. We said we had 3 segments. So I'm going to take both of these numbers and divide them by 3. 3 here, 3 here. This is going to tell me how far I got to walk on the graph to do a partition. So horizontally, 3 divided by 3 is going to give me 1. And then vertically, 6 divided by 3 is going to give me 2. This is showing me my horizontal and vertical change to walk the graph to be able to partition a line segment. Alright. From there, Now that I know my change in my horizontal change and my vertical change, I can partition, and I'm gonna show you by doing math, because doing it this way you'll never be able to get it wrong. With whole numbers you can kind of just walk on the graph and do it, but most of the stuff we do on here you're gonna see won't be whole numbers, so you're gonna have to do the math out to the side anyway. And I'm gonna show you how to do that math. To partition using these changes that we got right here, we're gonna start with a point that they told us to partition from, which was A to B. Point A is up here at the top, 3, 4. So A is at 3, 4. And then from there, my horizontal change is going to be my change in X. Horizontal change is my change on my X axis. So that's how I'm going to do my change in X. My vertical change right here is my change in Y. That's how my Y changes. So this is showing me my vertical change right here is 2. And these are both positive, so I'm going to do plus down here onto my points. So onto my points, I'm going to do a +1 for my change in X, and then a +2 for my change in Y. When I do that, I'll get my first partition. Now, the thing you got to understand too is how many partitions you need to do to get where you need to go. Looking back up here, my line was split into a ratio of 2 to 1. The first number tells you how many partitions you got to get to the point you need to get to. So from A to B, they want me to do 2 partitions, split it 2 to 1. So down here, I got to do my partitions twice. The first one I do is going to be 3 plus 1, which is 4, and then 4 plus 2, which is 6. That is my first partition. But I need to do 2 of these because my ratio is split 2 to 1 from A to B. So I got to do this a second time. My second one, all I'm going to do is do the same thing again, +1, +2. And then get to my second partition, which would be, that's 2P. My second partition is going to be 4 plus 1, which is 5, and then 5 plus 2, which is 8. So my second partition is going to be 5, 8 right here, and this is what I need. That's going to be my answer right there. So I just need to graph that. On the graph, walking it over, I'm just going to 5, 8 and putting in this partition point right here at P, 5, 8, and that's going to be my P. That's going to split that line in a ratio of 2 to 1. Alright, moving on to my next one. I want to go B to A. On this one, it says given points A, -3, 2, and then 6, 1. Just got to graph again real quick. -3. It wants to go -2, and then 6, 1. On this one, this is A and this is B. Like I said though, the main thing you need to pay attention to is how they told us to partition. They told me to partition B to A on this one. So this one I'm going from B to A, not A to B, B to A. And so if I'm going from B to A, I'm starting at B, and I'm skipping steps. The first step, figure out how many segments you have. This ratio is 1 to 2. 1 plus 2 is 3 segments. So I'm splitting this into 3 segments, like I did the last one. So this is 1 to 2 versus 2 to 1. And then they asked me to go B to A. So I'm starting at B. Step 2 says make my right triangle by counting my horizontal and vertical distance. But I'm going from B to A. I keep saying that so you understand. I'm starting here and then looking horizontally. I can't go to the right because A is to my left. So horizontally on this one, I'm going to start by going left. What I need you to understand about this, since I'm going left from horizontally, this is a negative change. I'm not going in a positive direction, I'm going in a negative direction. I'm going negative 1, 2, 3, 4, 5, 6, 7, 8, 9. I went to the left negative 9 spaces. And then to get to A vertically, from there, I gotta go down. I gotta go down, that's negative as well. I gotta go down 1, 2, 3. So this is negative 3. Make sure you represent your change on this one as negative 9 and negative 3. So out to the side, my horizontal, my H, is gonna be negative 9. And then my vertical is going to be negative 3. And then I need to do what I did on the first problem now. Divide by the number of segments I have, which is 3. Both of these things. Negative 9 divided by 3 is going to be negative 3. Ran out of room right here. Hold on. Negative 3. Negative 3 divided by 3 is negative 1. So my horizontal and my vertical change are going to be negative 3, negative 1 when I walk on the graph. But like I said, I'm going to just do it mathematically. So after I get those, I go to my partition point that I'm supposed to start at, which was B. It went B to A, so B for me, and they got it written right up there at the top. B was at 6, 1. And then from there, I want to partition my line using my horizontal change and my vertical change. Horizontal change, once again, is my change in X. My change in X was minus 3. My change in Y was minus 1. On this one, my split is 1 to 2. So all I have to do is do one partition to get to the point I need. So this first partition is the only one I have to do. One partition, and 6 minus 3 is going to be 3. 1 minus 1 is going to be 0. This will be my partition after one partition using the change in X and change in Y that they gave what I calculated. So my point is going to be at 3, 0. And then on the graph, I could just drop that on here. 3, 0. This is my partition point. Moving on to the next one. This one says, given these points, find the coordinates of point P direct on the direct line segment AB. That partitions AB into a ratio of 1 to 3. So we split in 1 to 3 on this one. Should be pretty easy for y'all to do this one. I might even pause and let y'all do it and see what y'all get. But I'm going to go ahead. Right, so A is negative 4, negative 3. B is 4, 1. So A, B, and then from there, first thing, figure out how many segments you have. Ratio is 1 to 3. So this is 4 segments. It's A to B, so we're going from A to B. and we want to do our triangle. Triangle from A to B is going to be to the right. This is 8 spaces, so it's a +8, and then we're going up 1, 2, 3, 4. That's a +4. So out to the side here, my H is going to be 8. My horizontal change, vertical change is going to be 4. I'm dividing by 4 segments. It's going to give me a change of 2 and then a change of 1. So from there, I just need to figure out how many times I'm partitioning. I'm only partitioning once because I'm doing a 1 to 3 split. So that makes this pretty easy. I'm starting at point A because it said A to B. Point A was at -4, -3. And then I just need to do one partition by adding a 2 and then adding a 1. One partition. -4 plus 2 is going to give me -2. And then -3 plus 1 is going to give me -2. So my partition is going to be -2, -2. Then I just put that point on. -2, -2. It's right here. Point P. Like I say, these are easy when it's whole numbers. The ones that are going to be challenging are probably the next couple that I show you, which you're not really going to like because I know y'all don't like fractions, but that is life and it is what it is, so we're going to keep it moving. This next one, this is going to be a fraction one. So like I said, if you don't have paper out, I got some paper right here for myself. You're going to need paper, I promise you, because it ain't going to be as easy as the other ones. Given the points A, -4, 7, and B, 8, 3, find the coordinates of point P on a directed line segment AB that partitions AB in a ratio of 3 to 1. Alright, so on this one, I'm graphing those points first. -4, 7, that's way up here. Make sure I put these points on right. And then the other one is 3, 3. So this is A, this is B. Oh, that says 8, 3, but now I'm looking at it, this was a typo on these notes. This needs to be 3, 3. So I'm reading that right, y'all. I'm looking at my old notes, or I printed the one with the typo in it. So this should be 3, 3. Change that to a 3. So I graphed that right, and I don't want you to think I graphed it wrong. Alright. Putting my line segment on. And from there, get my splits. Split is 4 segments. And then I'm doing my triangle to get my counts. From A to B horizontally, I have to go to the right. Going to the right would be a +7. So this is +7. Then I would have to go down though to get to B vertically. So that would be a -1, 2, 3, 4. A +7 and a -4. That's my vertical change, my horizontal change, and my vertical change. Horizontally, like I said, this is going to be a +7. Vertically, this is going to be a -4. And then we need to divide by 4 both. And so this is where you run into issues at. Not here, because you're going to get -4 divided by 4, which is going to give you -1. But up here, 7 divided by 4, and I skipped it because you can't divide 7 by 4. So since you can't divide 7 by 4, you have to leave it as is, to be honest with you. You can't do anything with it. 7 divided by 4, you're going to have to leave it as 7 over 4. And that's going to be your split for the horizontal one. The problem with that is we can't count. It's hard to add 7 over 4 or any fraction on the graph, or add it to a number like this. Remember, just like we did when we did the stuff the first week, to add and subtract fractions, you need common denominators. So it's not going to be as simple just to add that to these coordinates right here. We're going to have to do some manipulation. So that's why we need notebook paper. Alright. So on our notebook paper, we're going to start with the point that they wanted us to partition from, which was A, which was -4, 7. I'm going to put that point on paper. So on my paper, starting at point A, that was -4, 7. And then I'm going to look at, like I said, my change for horizontal was 7 over 4. And then my vertical change, that was just a -1. So for my vertical change, I can do -1 to this side right here easily. That math will be easy. The problem is going to be adding 7 over 4 to this side right here. To this side, before I can add 7 over 4, I need a common denominator. Like we did with the other stuff, my denominator is going to be a 4. So I just got to manipulate this side of my point, this -4, and I got to get it to have a denominator of 4. To do that, I'm going to put a 1 under it, like y'all have seen me do before. And then after that, I'm going to multiply the top and the bottom by 4 to get a denominator of 4. I'm changing this whole number to a fraction, something I can add and subtract with. So once I do that, my A then changes and becomes this. Point A then becomes this for me. -4 times 4, which is -16 over 4. Well, because 1 times 4. And then I'm going to leave the 7 as is. All I did was manipulate the coordinate a little bit so I can add and subtract to it. Let me zoom in a little bit for y'all. That should still make sense to you. All I did was manipulate this so I can add and subtract to it. Now that I did that, I can do my partitions. And they asked me for 3 partitions. But they want me to split this 3 to 1. So I'm taking that 7 over 4. That's positive. I'm adding 7 over 4 to this side. On this side, I'm going to just, it was a -1. So I'm just subtract 1. So first partition is going to be -16. Now that you got common denominators, you can just look at the numerators. -16 plus 7. That's going to leave me at -9 over 4. On this side, 7 minus 1, which will be 6. But remember, you got to do 3 partitions on this one. So I'm doing this again. Plus 7 over 4, and then minus 1. Second partition is going to be -9 plus 7, which would leave me at -2 over 4. And then 6 minus 1 is going to leave me at 5. And then got to do one more partition, which is plus 7 over 4 minus 1. And then that'll leave me at negative 2 plus 7, which will be positive 5, yeah, over 4. And then 5 minus 1, which would be 4. Alright. Yeah, and there. That's my third partition. That's where I needed to be, so that would be my answer. Sorry, I need to zoom out. Like I say, this is that most complicated one. It's the reason we saved it for last. It's just adding fractions. I know that's something y'all not fans of, but it is the situation, and it is what it is. It's something we just gonna have to handle and work through. But this is how you have to handle those ones where you have a fraction. Sometimes both numbers will be fractions. If that's the case, you're just going to do a common denominator on both sides and keep it moving. If not, then you can just roll. I think there's one of your practice that I will show you off video. That is where both sides are fractions, and I just want to show you how to do that one. Just for the sake of time of the video, I won't do that right now. I'll just do that, off the video. But there is one more in your practice I want to show you, just a decimal one that I want to show you. So on your practice, let me make sure I find the right number. On your practice, I think it's number 8. So if you go to your practice, and this is number 8 on practice. Make sure I got the right one. Yeah, this is it. So number 8 on practice. This is the one I want to do with you. Alright, real quick. Find the coordinates of point P so that it partitions segment AB into a ratio 1 to 3 with A at negative 2, 4 and then B at negative 7, 5. So A is at negative 2, 4. Negative 4, I'm saying that wrong. Negative 2, negative 4. B is at negative 7, way over here, up 5. Alright, so A is down here, B is going to be way up here. Zoom in a little bit. And on this one, first thing I want to do is figure out how many segments I have. 4 segments. You should know how I know that. 1 plus 3. Not a hard thing to figure out on these. And then from there, I want to make my triangle so I can get my horizontal and vertical count. Now, triangle on this one, they said A to B. So I'm going from A to B. To get from A to B on this one, I first start at A. And I have to go back to the left on this one to get to B. So to the left is negative move. Remember that. That's negative. And then I just need to count how many spaces I went over. 1, 2, 3, 4, 5. It's negative 5. And then I got to go up to get to B, which is positive. Up 1, 2, 3, 4, 5, 6, 7, 8, 9. So this is plus 9. So I went negative 5 plus 9. Alright. Horizontal was negative 5. My vertical was a 9. On this one, I'm going to divide by 4 for both of them because of the number of segments. And this is what I want to show you too on this one. Looking at this, you know you're not going to get a whole number, but I want you to look in your calculator because the decimals that you get are not bad decimals. On the one we did before, when we did 7/4, that decimal was like a horrible decimal. It's like some kind of run-on decimal. This decimal is not bad. What I mean is it's not like a repeating decimal or anything like that. It's just a clean decimal. Like when you do, for example, and you can do it for yourself in your calculator, -5 divided by 4, you're going to get -1.25. -1.25, that's what I consider a clean decimal. It's not run on. It's not a long decimal. You don't have to round it. You can leave it like that. If you get a decent decimal like that, you could just use that instead of the fraction. So I would use -1.25. That's easier for me. And then the other one would be 9 divided by 4, which is 2.25. Make sure both, honestly, if one of your decimals is good, the other one usually is. Just how it kind of works. But you know, both of your decimals are good, just use those. If you don't have good decimals, like something that's like I said, something that you don't have to round, then just use the fractions. But on this one, since these decimals are decent, I'm gonna just use those and do my partitioning. And so at the bottom here, but you got to do this mathematically though. You can't count this on the graph. You have to do this mathematically just because these are decimals, and you want to be accurate with what you're doing. At the bottom, I'm gonna do the work for these, not out to the side. I guess I could do it out to the side here. Now I got a lot of space down here. I'll do it down here. So my starting point was A, -2, -4. So down here at the bottom, I'm gonna go A, which is at -2, -4, and then from there, I'm do, well, it only asked me for one partition. Say 1 to 3, so I only need to do one partition. So I only need to do the horizontal vertical change once to this. Horizontal change, remember, was -1.25. Vertical change was 2.25. So I just need to do that math on here once to get my partition. My first partition, that's the only one I need to do on this one. It's going to be -2 minus -1.25, which is going to give me -3.25. And then on this side, -4 plus 2.25 is going to give me -1.75. So that is my partition, first partition. That's the only one I need to do. And it's going to let me here -3.25 and then -1.75 in the box. On these ones on practice and home learning, you'll see that we provided you boxes for your answers. Should have did that on the notes, but like I said, I realized I printed the wrong notes, so it just had a typo and it didn't have the boxes. But that's fine. Those notes are still decent. We can still use those. But yeah, this is partitioning. It's one of those things that's going to take practice. You ain't going to get it right off the bat. I don't expect you to be spectacular the first time you try this, but that's why we got a lot of practice. So you need to make sure you practicing this so you learn how to partition a line segment, because it is some question that is asked standardly on the EOC. They asked it a couple times too, at least. So it's something that a skill you need to know how to do. All right, so that's it for my notes. Anything else I'll show you off cam. Like I said, feel free to go back and watch this video as many times as you need to help you.